So I'm looking for an f of x. I've got two pieces. Here's one piece. Here's two pieces. So I label my two pieces. It's going to be something if now x is something and something if x is something. So I need to fill in the blanks. Easy part is the domain. I notice the domain of the first one starts at -1 and ends at 0. And it's solid dot both ends, which means it includes both pieces. So that says as long as x is greater than or equal to -1 and less than or equal to 0, it's this piece of graph right there. The next piece of graph picks up 0, which is an open dot, and goes and stops here at 2. So it's from 0 to 2. But not including 0 because it's included in the other guy. So in this case, x is going to be greater than 0, solid dot at the other end, less than or equal to 2. So domains are the easy part. So the first graph is -1 to 0. Second graph is 0 to 2. And now I've got to get the formulas for the two graphs. So graph 1 is a line. What do I need? I need the slope of the line, and I need a point on the line. Well, a point is easy because it's 0, 0. I like anything that's that way. And a slope is easy too because slope is rise over run. So I have a run positive from -1 to 0 and a rise from -1 to 0. So I look at the slope as being 1 over 1, which is 1. So I know that y minus 0 equals 1 times x minus 0, or in this instance, y equals x. Remember, f of x is just a y value. So that says y equals x as long as x is between -1 and 0. Graph 2 is a horizontal line. And if a horizontal line, that means that it is y equal what? Y equal 1. Yeah. It's always, horizontal line is always the y value because it's flat. So no matter what x value I pick, y is 1. So that says y equal 1 if x is between 0 and 2. Vertical lines are always x equal. Horizontal lines are always y equal because they're constants. Vertical, x never changes. Horizontal, y never changes. How many pieces do I have this time? 2. So I'm going to come back in and label them. Here's graph 1. and here's graph 2. And I want an f of x, that's a y value, that's equal to something if something. It's the way the test question appears, by the way. You fill in the blank. They're both lines. Yippee! Woohoo! Now, the first domain starts at -1 and stops at 0. Solid dot both ends, which means it includes -1 and 0. So that says if x is greater than or equal to -1, but less than or equal to 0. The second graph also starts at 0, but goes on forever, which means it goes from 0 to infinity. So this is going to be x strictly greater than 0 because he's an open dot. By the way, the second one is the easiest. Why would I say the second one is the easiest? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Name that line.
X equals y.
X equal y. Woohoo! So, this guy is the easy one because he is y equals x. So, remember, this is y equals x if x is positive. So it's like, yes. Other one, not so much. I have to do a little bit of work. So for the first graph, I need the slope. I need a point, and I think I'm going to pick 0, 2. Why would I pick 0, 2? I don't want a negative number. You're right. Oh, he knows me so well. So that says I go over 1. I go up 1, 2. So rise over run is 2 over 1. I have a slope of 2. So the slope is 2. And I have the point, which is 0, 2. Now here's the question. Anybody recognize that point?
The y-intercept?
0, 2 is a y-intercept. Woohoo! In the world of mx plus b, he is b. Now, you might, which means this happens to be y equals 2x plus 2. However, if you're not in that vein, just do what I would do most of the time. Y minus 2 equals m, which is 2, times x minus 0. I have to solve for y in this instance, don't have a choice. Or y equals 2x plus 2. So you don't have to be cutesy about it. So y equals 2x plus 2 if I'm on the other side.